Thank you, Dylan, for the introduction. I also want to thank everyone for calling in today. I've been able to work on some interesting projects over the past 6 months, and I'm excited to show you all what I've been able to accomplish. So, a little about me. I'm from Sanford, North Carolina. I'm currently studying mechanical engineering at the University of North Carolina at Charlotte, with an anticipated graduation date of December 2021. Outside of school, I enjoy playing pickup basketball, water and snow skiing, and then just enjoying the outdoors in general. For previous work and leadership experience, last summer I had the opportunity to complete a robotic design internship at Dymond in Lisbon, Portugal. Dymond is an international startup that focuses on research within the robotics industry. And during my internship there, the main project I worked on was to design and manufacture a five-axis robotic arm using 3D printing and CNC machine. For leadership roles, I currently serve as the Senator for the Lee College of Engineering within my university's student government. In addition, I'm in the Lee College of Engineering Leadership Academy. I'm the Vice President of Scholarship in Alpha Sigma Phi fraternity and a graduate of the National Outdoor Leadership School, also known as NOLS, where I completed a 30-day backpacking trip in Alaska that was centered around teaching leadership in the outdoors. So for my work plan, I had a unique experience at Cummings where I was able to work in two different positions during my co-op. I began working in the current product team in January before moving to ATA 2024 team in the middle of March. And here I have listed the projects I've completed on each team. On the current product team, I worked with fixing warranty issues on current products. And then in the ATA 2024 team, we were designing the after treatment system for 2024. The first project I worked on within the current product team, I inherited from a coworker, and it was a coupler cost reduction project. The cost reduction was a result from switching to a new, cheaper supplier, and in the process of switching, the new supplier found undefined dimensions on the print. So after correcting the dimensions, a DVA study needed to be conducted to confirm that the changes still allowed for sufficient wall thickness. So the objective of the project was to define the missing dimensions and conduct a true position DVA study on the wall thickness. Task I completed, I began by conducting a DVA study on the worst case for the coupler's wall thickness using true position tolerance. Next, I completed the print corrections for the 4 couplers with the dimension changes that were agreed upon by the supplier and the manufacturing. And then current status of this project, the prints now have fully defined dimensions and the TP tolerances still remain sufficient. And the impact of this project was that the $150,000 per year cost reduction was able to move forward due to the print corrections and the additional DVA study I conducted. The second project I completed in the current product group was a T-bolt material addition. The current bang clamp was using a T-bolt and nut made from the same material, and having two of the same materials paired together is notorious for causing galling issues. And the objective of this project was to validate the use of an alternative T-bolt material in order to prevent future galling issues. So task I completed. So my manager helped me identify the requirements that the T-bolt material were going to have to meet. By using the materials that had previously passed these requirements, I compared their properties to the new material's properties. And then the new material was required to show that it would perform equal to or better than the existing T-bolt in each of the different requirements. So next I took all the parented tests and the material property comparisons and wrote 2 different documents. One specified was specifically reusing data, and the other one was new data in order to show how they passed each of the different requirements. And then I created a virtual design review covering my findings in both different documents and held a design review where all key attendees approved adding the material to the T-bolt print. So the current status of this project is that all the CTRs, which are the important documents, and the print of the T-bolt have been released. The impact of this project was that I was able to help prevent future galling issues on the bang clamp and thus reduce the future warranty issues. My first project within the 2024 team was to conduct body joint force calculations on the current 2024 design. Due to 2024's increased length and weight, the forces on the body joints were a concern. So the objective of this project was to analytically compare the shear and moment forces on the 2024 body joints to the forces on the past systems, and use the results to determine if the current band would be able to be used for the 2024 design. So task I completed. So using an existing body joint calculator, I calculated the moment and shear forces across the length of the horizontal system. Next, I created a calculator that shows the forces on each body clamp if any of the other body clamps were removed. So for example, it will show the forces on the first body clamp of the design if I did not have the second one. If I didn't have the second one, but I had the third one. Also produced a calculator that determines the optimal location for the SER mounting zone if a design were to change from 2 mounting zones to 1. Additionally, the calculator also shows how the forces on the body joint changes and result to switching from 2 to 1 mounting zones on the SER. So the current status, I've completed the calculators mentioned above and will continue to support the project in expanding the calculations to vertical systems and any additional applications throughout my co-op. The impact of this project was that these force calculators will be able to be used across Cummings emission systems for future projects. It will reduce the time to produce the shear and bending moments across a variety of systems. The water trap concept analysis was my first time running CFD analysis. The objective of the model of the project was to model the concept in Creo and complete designer-level computational fluid dynamics analysis in order to provide insight into the concept's performance. So task completed. I started this project off by modeling the concept in Creo based off a hand drawing I received from a colleague. I created 2 different versions of the concept. The first version was meant to minimize the length of the water trap while maintaining a reasonable back pressure. On the other hand, the second version was lengthened to allow the greatest amount of open area while maintaining the distance between the DOC and the inlet. I created these 2 variations in order to show the relationship between the water trap length and the back pressure. Next, I conducted the CFD analysis in Fluent, referring to a tutorial made by Pranjal, and with the continued help of both Lindsay and Pranjal, I was able to obtain the back pressure drop across the concept and also the FDI at the entrance of the DOC. Lastly, I completed the post-processing, and the results were compared to the analysis Lindsay ran on the remaining concepts. So the current status of this project is after analysis was compared, it was decided to move forward with a different concept. All the analysis was conducted, was documented in a CTR, which is just a document. And the impact of this project was that the database decision making ruled out this concept without the need of costly physical testing. Another one of my projects within the 2024 team was to run analysis on 6 different concepts for the NOx sampling device. So the objective of the project was to use CFD results to conduct A to B comparisons between the concepts in order to narrow down to the top performers. So the task I completed. So I completed pre-processing on the CAD documents before importing them into Fluent, where I used the program Design Modular to create the flow domain for the concepts. Once I completed the run, I collected the data we needed. In this case, we were focused on mainly the back pressure drop and the mass flow rate into the NOx wheel. The NOx sensor was a requirement for how much airflow needs to reach the sensor before it can take an accurate reading. So the current status of this project is that we are in the current process of running additional concepts, and we make a decision based off the results. The impact of this project was that I was able to quickly and at a relatively low cost evaluate the performance of each of the NOx sampling device concepts. Analysis on side inlet perf plates is my final project that I've begun. The objective is to run CFD analysis on the perf plate designs in order to create a design that meets the acceptance criteria for the FDI entering the DOC. So far in the project, I've completed CFD analysis on the baseline and on a new design for the perforated plate. So after comparing the 2 designs, the new concept did result in FDI closer to the acceptance criteria than the baseline. So the current status of this project is that I will continue to support the project in running analysis on new concepts, and in the coming weeks I will be learning how to use Mode 3 Frontier mode frontier, which will allow me to set variables to optimize the design. An example of this would be setting the distance of the perf plate to the DOC as a variable. The program would then determine the distance the perf plate should be away from the DOC in order to optimize the FDI. So the impact of this project is I'll be able to provide an A to B comparison of FDI results between two concepts, and will continue to use the results to help optimize the perforated plate design. So highlights of my co-op. So on the drive from North Carolina, I had the opportunity to stop and visit Chicago for the first time. So my sister and I went to all the different tourist attractions, the Bean, Sears Tower, got some deep dish. That was fun. And then also just being able to live in Madison and experience a different part of the country has been a great experience for me. I had the opportunity to meet people from all over and learn about the differences in places we came from, which is good knowledge to have when I'll soon be choosing where to live after graduation. I also enjoyed getting to know my coworkers. Everyone I've worked with has made the transition to companies much easier than I was expecting, and I've really valued the relationships I've been able to make over the past 6 months. I also have had a unique experience where I had to roll over the relationships I built in person to being able to speak online. I had to adjust to taking the initiative of reaching out to people in order to stay connected because we no longer ran into each other around the office. In closing, I want to give a special thank you to Dylan, Kyle, and Tyler, along with everyone throughout the company for being a huge resource throughout the recruitment and intern process. You're the reason I was able to transition so successfully into my positions and have a meaningful learning experience over the past 6 months. Lastly, I appreciate the opportunity to continue working with my team till mid-August, and specifically thank you, Dylan, Tyler, Tom, Jeff, and everyone that provided input into the decision to extend my co-op. It really does mean a lot. Thank you, and I'll open the floor to any questions.